Okay, cool. So, as I said in the previous video, customer usage attribution ID and plan are already correct. What's missing now is a concrete configuration about our ISV backend. But before going into configuring a bunch of things, it might make sense to actually provide some architectural context about how the different bits and pieces fit together. So let's have a look at the diagrams here. First of all, okay. So we start with the overall architectural picture. So in this example, we do have multiple customers who purchased the managed application. So you can see the managed application is running inside the boxes of customer 1, 2, and 3. The boxes are sending all these deployments, so to say, send the usage information, the metered billing usage, to a central instance of the metered billing accelerator or aggregator in the ISV or the publisher backend, which then centrally aggregates all that data and forwards it to the marketplace metering API from Azure, from Microsoft. It is important to note, and you might remember we already configured in Marketplace the credential of this arrow here, where the metering aggregator talks to the Marketplace API. The problem is the communication from the application to the metering aggregator. We are basically dumping messages here in EventHub. And these calls do happen across an organizational boundary. The managed application is running inside a customer subscription which belongs to a customer's Entra ID tenant. And the EventHub endpoint here from the metered billing aggregator is running in the ISV subscription, living in the ISV tenant. So the question is, which credential can we use to authenticate and authorize these calls across the organizational boundary? And this video is primarily about explaining like why and how we are doing this. But first, let's zoom in to the actual metering aggregator itself. So the metered billing accelerator is a compute component, the yellow thing here, and storage services. So in this case, I treat EventHub basically as an append-only log storage, so to say, to keep a history of everything that happened in my deployments. The aggregator reads all that information and captures it in snapshots and stores these in the state snapshot here. So what are all these usage events and what's the overall life cycle? So when somebody purchases the solution, somehow the metered billing accelerator needs to understand that there is a new customer, a new deployment for which usage is supposed to be tracked. This subscription event comes from some management application. So some endpoint, some service needs to tell the metered billing accelerator, hey, there's a new customer. This is the subscription details. This is a plan. Please start tracking usage events for this customer. And then we have the actual application, which I called here sending application, which is sending all the usage events into the billing accelerator, in this case into the EventHub's into the EventHub's endpoint. So the management application says, hey, there's a new customer, or a customer deleted their deployment, so stop tracking and submit the rest of the charges and then stop tracking for this customer. And the actual application is the upper red box, which sends all the information into EventHub. So you see usage events flying in from here and subscription events flying in from the management application. Inside the metered billing accelerator, we have the aggregation component, the aggregator, which does a couple of things. So when it boots up for the very first time, it looks in this state snapshot storage. This is just a storage account container, whether we have a previous state from which we can start working on. And each state snapshot basically contains a position in event hub to which it belongs. But let's assume we start fresh, nothing ever happened, we're at the beginning of time, so to say. So in this case, the aggregator positions its reader, its event reader, at the very first event in event hub, or alternatively, it can read from capture, and it's then basically processing each event exactly once. So the event reader is reading all the information from an Azure Event Hub partition, and it's forwarding all these events to the business logic. And the business logic basically applies one event after the other in an event sourcing fashion. So how does this event sourcing thing work? You can imagine something like this. When the aggregator starts, it has a null state, so to say. And for each event, event number 0, 1, 2, 3, and so on, all the events that show up in a certain partition in Event Hub, we are basically sending this event and the previous state into a function, which basically computes a particular state. So by combining the null state, an empty system, and a first event, it creates a first state. So that first event is something like a new customer has purchased our product, and here's the subscription ID of that customer and the plan, right? So the state in this case would just contain the information that there's a new subscription. And the second event might be that usage happened, right? So then it basically says, okay, we have an existing subscription in the state, and usage happened, and so we do the accounting thing and say, hey, the counter of usage incremented by 1 or something along the lines, and this shows up in state number 1. And this is exactly what happens inside this system. So the business logic takes in the previous state and an event and creates a new version of the state. And this state is then either or both regularly snapshotted by a snapshot generator component and written to storage. And we are also remembering inside the state about which usage should be sent to the Azure Marketplace metered billing API. And so this emitter component here basically sends API requests to Microsoft, and the responses of these API calls get sent back into Event Hub. These API response events get sent back into Event Hub, so we can also track Microsoft's responses. So for example, this means, like at the logic level, during an hour we say, hey, certain usage happened, like customer 1 consumed, 5 widgets and 3 widgets. Now we have a total of 8 widgets for the given hour. And yet another widget, so now we have 9 widgets consumed. And when a new hour starts, and this information, by the way, is now in the state, right? So 9 widgets in the current hour. And when a new hour starts, the emitter component basically sends the information about customer has consumed 9 widgets to Microsoft. And when Microsoft says, thank you very much for the information, we recorded this in our accounting system, that response is sent back into Event Hub and also flows into the business logic. So the business logic then says, oh, I wanted to have recorded that a certain customer has consumed so much information, and Microsoft confirms this. Therefore, we can remember that this hour is basically done and successfully submitted. This is why you have a feedback loop basically from the emitter via Event Hub back into the business logic. Okay, so but now let's actually skip this kind of how does the metered billing accelerator work inside and go back to our deployment story. So the Event Hub and the aggregator and the snapshot are basically running inside the publisher subscription here, and it's talking to, no, this is actually not Entra ID. This is the metering API. So this is the metering API over here from Microsoft. So how does the whole thing fit together? The problem is this: when the virtual machine is supposed to send a call over the organizational boundary to EventHub, we need some sort of valid credential for EventHub. And EventHub only accepts Azure Entra ID identities from the publisher's tenant. So we somehow need to get a valid credential into the virtual machine and store it somewhere. We store it in Key Vault, but where does the credential come from? So here's the thing. We created a REST API here, which we host on the publisher side. And when a new ARM deployment, a new managed application is purchased by a customer, the ARM deployment calls into the REST API and says, hey, I'm a new managed application. For this customer and this subscription, please create a service principal credential for me so I can submit the usage to EventHub. But how can we securely call this REST API? Again, we need some sort of credential. This is where Key Vault comes in. So there is a mechanism in Azure Marketplace Managed Applications where you can authorize a Microsoft applications, the so-called appliance, the appliance resource provider, I think, to read secrets from a Key Vault during deployment, very specific secrets. It needs to be authorized, right? So we put the REST credential into Key Vault, and when the ARM deployment kicks off, it reads first the secret from Key Vault. It then calls the REST API here, and the REST API creates a new service principal in Entra and adds a service principal to a security group, which is authorized to publish to EventHub, and stores the secret in Key Vault. And then the ARM deployment fetches the service principal credential from Key Vault on the publisher side and stores it in the Key Vault at the customer side. And then the customer virtual machine can use a managed identity to talk to Key Vault, and then has a service principal credential to send stuff to EventHub. If this was confusing to you, no worries, we got you covered. So this part up here, we coined the term shared resource broker pattern for this. So the shared resource broker is basically about figuring out how can we get a credential, a service principal credential from the publisher side for this particular managed application into the customer side. So let's zoom in how the overall interaction flow looks like. So in this swim lane diagram or sequence diagram, we have a couple of parties. So these left 5 bubbles basically run at the customer side. The other 3 are on the ISV side. First, the customer purchases the application via Marketplace, which is our step number 1, and an ARM template kicks in, which deploys the managed application. This ARM template needs information about where can I find the secret. We call this bootstrap secret. Where can we find the bootstrap secret to call the REST API? So first of all, this bootstrap secret in step 0 needs to be stored in a publisher Key Vault here. And the REST API, which we're running, fetches this bootstrap secret to authorize incoming requests. This is step number 0. So when a customer purchases the application, the ARM template at the customer side calls the getSecret API to get the bootstrap secret out of the publisher's Key Vault in step number 3. We then run a deployment script inside the managed application template to trigger the creation of a service principal. So inside the deployment script, we basically use a bootstrap secret, and you make an HTTP request against the publisher's REST API here. And when this call comes in, the REST API knows, okay, there's a new managed application. These are the IDs, this is the customer, and so on. It goes out to the publisher's Azure AD tenant. It creates a service principal, and it adds that service principal to a security group. Why? We didn't want to have a situation where when multiple people purchase a managed application, we constantly need to do additional role-based access assignments on Event Hub. We basically want to say all managed applications can publish to Event Hub, and we just add the service principals to the managed application security group in step number 6 here. Rather than returning the secret back to the deployment script via HTTP, we store this service principal credential for the particular managed application in a time-boxed, time-bombed secret in Key Vault as well. So we store the service principal credential in the Key Vault at the publisher side and just return the secret name back to the deployment script, which returns us back to the template. And then the appliance resource provider from Microsoft does the legwork in step number 10 to fetch the specific service principal credential from the publisher's Key Vault for this managed app deployment and store it in a Key Vault inside the managed application. So this is our store service principal credential here in step number 11. And then, of course, our ARM template needs to deploy, user assigned managed identity, authorize the user assigned managed identity to read that service principal credential and creates a VM and all the good stuff, right? But for the sake of the shared access broker, this is basically it.